This film we're gonna talk about different materials that is used in engineering. The first material that I will talk about is aluminum. Aluminum is derived from the oro bioxide. First bioxide is mined from typically shallow deposits, and then it is refined into alumina using the Bayer process at an alumina refinery. Firstly, crushing and grinding the alumina, starting by passing the bioxide through screens to sort it by size. The second step is digesting. The slurry is pumped to a digester where the chemical reaction to dissolve the alumina takes place. Thirdly, settling. And fourth step is precipitation. And finally, calcination. Calcination is a heating process to remove the chemically combined water from the alumina hydrate. Aluminum, it's a metallic, non-ferrous alloy, and it has a melting point of 660.37 Celsius. Aluminum, it's a lightweight compared to the other materials. There's many objects that contains aluminum. For example, soft drink cans, house side panels, and laptops. The second material that I'll talk about is copper. Copper is found in many parts of the world. It usually comes from copper ore, but small amounts are found in distorted cubic crystal chunks, which is a native copper. The process of extracting copper from copper ore varies according to the type of ore and the desired purity of the final product. Each process consists of several steps in which unwanted materials are physically or chemically removed, and the concentration of copper is progressively increased. Some of these steps are conducted at the mine site itself, while others may be conducted at separated facilities. Copper, it's a metallic, good conductor for electricity, non-ferrous, and it has a high thermal stability. Also, it has a melting point of 1085 Celsius. Examples of objects contains copper: printed circuit board, lead-free solder, and electromagnetic motors. The third material that I'll talk about is plastic. Plastic are either found naturally or synthetic, man-made. The majority of everyday plastics are synthetic. From crude oil, compounds are formed called polymers, which is plastic. Plastic can be found naturally and occur in such things as plants, trees, animals, and insects. The production of plastic can be divided into four categories. Firstly, acquiring the raw material or monomer. Secondly, synthesizing the basic polymer. And thirdly, compounding the polymer into a material that can be used for fabrication. And finally, molding or shaping the plastic into its final form. Polymers in general has a different number of melting points, but the most common plastic has 260 Celsius. Plastic are exotic compound, membrane, non-metallic, and polymers. There are many objects that contains plastic. For example, clothes, mobile phones, and remote controls. The fourth material that I will talk about is rubber. Currently, most rubber is produced using petroleum. However, more than 1/4 of all rubber produced is derived from latex extracted from living trees. The two sources produced different types of rubber with different properties. The production process of natural rubber begins with the cultivation of rubber trees. Rubber trees must be allowed to grow for about 7 years. After 7 years, a tree will normally produce about half a cup of latex per day. Once the latex has been collected, it will be mixed with a diluted acid. The rubber acid mixture is then rolled twice. The first rolling is to remove excess water. The second rolling is to texture the rubber. The rubber is dried and can then be sold or exported. Copper is a non-metallic compound, polymer, membrane, waterproof, man-made, and it has a melting point of 180 Celsius degree. There are many objects that contains rubber. For example, lab gloves, eraser, and tires. The next material that I'll talk about is steel. Steel came from iron, which is usually mined in the form of an iron ore. Steel is made from iron ore. The ore needs to be smelted in order to extract the iron. Smelting is done in blast furnace, where coke and limestone are added to the iron ore. This mixture is heated to a very high temperature and air is blown through it. The molten iron is drawn off. To make steel, iron is mixed with carbon and other metals to give it extra hardness. Steel, it's an alloy, ferrous, tough, rough, corrosive, and it has a melting point of 1300 Celsius to 1500 Celsius. Objects that contains steel: scissors, knives, and rollers. Stainless steel. Stainless steel is composed of iron, carbon, and chromium. The steel making process begins with the extraction of chromite in an underground mine. A sintering plant and two electric smelting furnaces are used to convert the chromite concentrate into ferrochrome. Stainless steel production is based on recycling, with the main raw material being recycled steel. Melting takes place in an electric arc furnace, which is charged with the recycled steel and other raw materials. Slabs arriving from the steel melting shop are turned into coiled bands in a hot rolling mill. Coils produced by the hot rolling mill are covered in black scale. In the cold rolling plants, coils are unrolled and placed along an annealing and picking line. Heat and chemical treatment line, removing the scale and changing the steel surface from dull black to silver gray. Stainless steel, it's a metallic, ferrous alloy, waterproof, and it has a melting point of 1510 Celsius. Here's some examples of objects contains stainless steel. First example is sink. Second, trash baskets. And finally, spoons and forks. Next material, it's zinc. Zinc comes from natural mineral deposits of ore in the earth crust. The deposits may be close to the surface, in which case they will be mined from an open pit. Alternatively, they may be some distance underground and cannot be mined directly from the surface. Zinc can be produced by a process called fourth flotation, which is also used for reduction of copper and lead ores. This process involves grinding the zinc ore to a fine powder, mixing it with water, pine oil, and flotation chemicals, and aerating the mixture to float the zinc to the surface. A variety of chemicals are used to coat the important zinc particles and prevent them from becoming wetted by the water. The air is injected, and the coated minerals attach themselves to the bubbles. The operation is performed inside a vat and agitated with an impeller. Zinc, it's non-ferrous, metallic, and it has a melting point of 421 Celsius. Objects contain zinc. AC, washing machines, and refrigerator. The next material is iron. Iron was created in massive stars and then released through supernova explosions over time. It was bound up in rocky material and helped to form planets. Charging the blast furnace. After processing, the ore is blended with other ore and goes to the blast furnace, separating the iron from the slag. The melted iron sinks to the bottom of the furnace. The limestone combines with the rock and other impurities in the order to form a slag which is lighter than the iron and floats on top. Treating the gases. The hot gases produced in the chemical reaction are drawn off at the top and routed to a gas cleaning plant where they are cleaned. Iron, it's a conductor, metallic, ferrous, and it has a high thermal stability. Rust, and it has a melting point of 1535 Celsius. Here's some objects that contains iron. Televisions, power transformers, car bodies and engines. Next material is bronze. Bronze is an alloy of tin and copper and is lower in the reactivity series than iron. This means bronze is easier to get out of its ore than iron. So bronze was found first, and once we got good at getting bronze, it was easier for us to extract iron. Today bronze is made in factories using the latest technologies, but the process itself is initially the same. Copper is melted to a temperature of around 1000 to 1200 degrees Fahrenheit. Other compounds are added to give it strength and other specific qualities. For example, tin gives it strength, phosphorus may be added to give it even more strength, and gold tint. Aluminium may be added to make it extremely hard and non-corrosive. Silicon may be added to give the bronze a red gold luster, often used for artwork. Bronze is a conductor and it has a melting point of 960 Celsius. Also, bronze is an alloy and durable. Here's some objects that contains bronze. Porthole and valves. The last material that I will talk about is lead. Lead is a metal found naturally in the environment as well as in manufactured products. The major sources of lead emissions have historically been from fuels in one-road motor vehicles, such as cars and trucks, and industrial sources. There is 8 steps for that. Firstly, mining the ore. Secondly, concentrating the ore. After the ore is removed from the mine, it's treated at a concentrating mill. Concentrating means to remove the waste rock from the lead. After that, the flotation, then filtering. After that, roasting the ore, blasting, refining, and finally casting. When the lead has been sufficiently refined, it's cooled and casted into blocks which may weigh as much as a ton. This is the finished product. Lead, it has a low thermal stability and it's non-ferrous, metallic, and it has a melting point of 327.5 Celsius, and it's also waterproof. Most of objects contain lead, but my only example is car battery. Thank you for watching my video.